Good morning, good afternoon, good evening. Thank you for joining me today. My name is Robert, and I'll be your host on this webinar. The title is Understanding Arduino for the ARM Learning Challenge. Our schedule for today will be as follows. First, we will cover the reasoning behind the ARM Developer Learning Challenge. Next, we will discuss Arduino. Then we will look at ARM. And then we will talk about microcontroller development boards. And we will finish off by looking at the Arduino IDE. So let's get started. First, let's talk about the reasoning behind the ARM Developer Learning Challenge. There are a number of microcontroller development boards out there, and these are manufactured by various companies. These microcontrollers get used by other manufacturers who put them into their products. These microcontrollers need to be programmed, so someone needs to do the job of programming them. Now, on the African continent, we're typically used to software developers only building software for either desktops or mobile devices. So we've come a long way with building communities around desktop and mobile, but we haven't looked at the world of microcontrollers, also called embedded systems. So the point is for us in the year 2022 to bring together various enthusiasts, various students, and even industry practitioners, and to get them to learn together. And for those who have already learned these things, for them to serve as mentors. So that's the point of the learning challenge, to bring people together on the African continent and get them to learn. Now, there are two tracks for this. One is the tiny machine learning track, and the other is the embedded systems track. Both of these will require the use of an ARM-based microcontroller, but the programming is done via the Arduino IDE. Now, some people might have some experience working with the Arduino IDE, but for some others, this might be the first time that they're hearing about it. And the point of this webinar is to get people introduced to the Arduino IDE before they get started with the learning challenge. Now, when we come together as a community, the world starts to take notice. So part of the goal is for the world to become aware of embedded systems engineers on the African continent, and for them to start to target their recruitment processes towards the embedded systems engineers who live on the continent. We're hoping that as a result of this learning challenge and the buzz that we create, that people get job offers where the jobs exist. Now, as I mentioned, the two courses, the tiny machine learning course as well as the embedded systems programming course, will utilize the Arduino IDE. For that reason, I thought it best to bring people together and talk about what exactly Arduino is. So Arduino itself is three things. There's Arduino, the company, which is an Italian company. There's Arduino, the hardware, which is open source electronics. and we're going to get to take a look at the most popular face of that open source electronics. And there's also Arduino, the integrated development environment, which is the workspace where you get to write your code, compile the code, and then that environment flashes the firmware at the end of the day onto the microcontroller. Now, one of the things that you will notice when you come to the Arduino ecosystem is the Arduino Uno R3. It's usually the first board that people get to work with. And one of the things I want to highlight is the processor on that board, which is the ATmega 328P. The instruction set architecture on that is the AVR instruction set, and it's an 8-bit instruction set. Now, I'm highlighting this board because this board doesn't work for the ARM Developer Learning Challenge. So both courses require completely different boards. There are boards that are manufactured by Arduino that work for the challenge, but this particular board and any board that is an ATmega or any board that uses a microprocessor from Atmel is not going to work for the challenge. So I'm going to cut over now and show you a video of the Arduino Uno R3, just for the sake of those who have never seen the board.
This is the Arduino Uno. For most people working with the Arduino IDE or within the Arduino ecosystem, this might be the very specific board that you're familiar with. If you look at this board, it has its I/O pins along the top and the bottom. The board is labeled with various components. So at the top, you'll see things like digital with pulse width modulation. And at the bottom, on the left, you have power, and on the right, you have analog in. I will also highlight the microcontroller as well as the USB input and the power input.
Okay, so now we're conversant with your typical Arduino Uno, but we need ARM-based microcontrollers for this learning challenge. So what is ARM? Similar to Arduino, ARM is multiple things. First of all, there's ARM, the company, and that is a British company based out of Cambridge. And it's the world's biggest licensor of intellectual property, silicon intellectual property. That is, it licenses the chips that you have in phones, microcontrollers, TV set-top boxes, and even some computers. So there's ARM, the company, there's ARM, the instruction set architecture, and there's ARM for the processors. So we typically would just call them ARM-based processors. The actual manufacturing of those processors is handled by different companies. For example, Snapdragon and MediaTek make microprocessors that go into your phones. So those are two companies that you might see out in the wild, but there are a bunch of other companies that also manufacture processors that are ARM-based. If you visit the ARM website and you go to the product section, you'll see something similar to this, where they're going to highlight various products. On the first column and the first row, you will see CPUs and MPUs. So they license processor intellectual property for a wide range of devices, all the way from sensors to servers. On the second column, you will see a number of products. On the third row, you will see Cortex-A. And Cortex-A processors are for application processors for devices that are undertaking compute tasks, complex compute tasks. And Cortex-A processors are what you will find in phones, what you will find in your Raspberry Pi, for example. We have Cortex-R processors, which is what you will find in real-time applications like automotive systems. And we have Cortex-M processors, and these are processors that you will find in microcontrollers. So they're low-power processors for constrained and energy-efficient applications. And for the purpose of our learning challenge, the microcontrollers that we use will feature a Cortex-M processor. So when you get to the Tiny Machine Learning course, the microcontroller development board that is advised to use for the course is one that is made by Arduino, and it's called the Arduino Nano 33 BLE Sense. It's a bit of a mouthful, but essentially the board itself is the Arduino Nano 33. BLE stands for Bluetooth Low Energy. So what that means is if you use that board, you're able to utilize the Bluetooth radio on it for communications if you would like to. The sense in the name implies that there are a bunch of sensors on this microcontroller development board. So it comes with a host of things. There's temperature, humidity, pressure sensors. There's an inertial measurement unit, so you're able to measure motion, acceleration, gyroscope as well. So this board features an ARM-based microprocessor, and that microprocessor is manufactured by Nordic Semiconductors, and it is a 32-bit ARM Cortex-M4 processor. So if you recall, when we looked at the Arduino Uno R3, that had an 8-bit processor with an AVR instruction set. This has a 32-bit processor with the ARM instruction set on it. So there are a number of microcontroller development boards out there. Coming from Arduino, we have the Arduino AVR boards, such as the Uno R3. Also from Arduino, we have ARM boards. And so these are microcontrollers that are ARM-based, and these are Cortex-M. And for example, the Nano 33 that we just looked at, and some variants of it. Now, there are also boards that are called RP2040. And these RP2040 boards are made by different manufacturers. Arduino makes a variant called the Arduino RP2040 Connect. Raspberry Pi, which is the designer of the RP2040, has a version of the RP2040 board, which it calls the Raspberry Pi Pico. And there are other variants. Now, the RP2040 boards are interesting because, first of all, they are Arduino compatible. Whether or not they are made by Arduino, you're able to utilize the Arduino IDE to program the RP2040 boards. They're also programmable using a C language SDK. So if you don't want to use Arduino, it's fine. You can go ahead and use your C language SDK. Now, they're also programmable using MicroPython, which is a subset of the Python programming language. So this makes the RP2040 boards approachable to individuals who are new to the microcontroller world and who are not particularly comfortable with C programming. Now, there are other boards made by other manufacturers that are programmable using the Arduino IDE. And so we will call these Arduino compatible boards. And then there are other boards that are not made by Arduino and they're not programmable by Arduino. One example of this is the Sony Sense.
We have another board up now, and that's the Arduino Nano 33 IoT board. You might or might not have come across this board within the Arduino ecosystem, but I'm highlighting it because the instruction set architecture or the microprocessor on the board is completely different from what you have on the Arduino Uno. This board features an ARM-based microprocessor, and for that reason, it's usable for any of our tiny machine learning projects. I've also dropped the Nano board beside the Arduino Uno, so you get a sense of the size of the board. We have another board up on the screen, and this time around we have the Arduino Nano 33 BLE. BLE stands for Bluetooth Low Energy. Again, this board is seated beside the Arduino Uno for size comparison. This board also features an ARM-based processor, and for that reason, we're able to use this for tiny machine learning. The board we have up now is from Arduino's professional series, and it's called the Portenta H7. This board has 2 microprocessors on it, both of which are ARM-based. It's the most powerful board that Arduino makes at the moment, and because the microprocessors are ARM-based, they're also useful for our tiny machine learning projects. This board is not made by Arduino. It's assembled by a company called RDCOM, and it's an extension of another board which is called the Raspberry Pi Pico, and that board is made by the Raspberry Pi Foundation. Now, the RDCOM Pico4ML is an interesting board in the sense that it has add-ons, some of which you can see, such as the camera, and some others that you can't see. There's an LCD screen on the opposite side of the board, as well as a microphone. Now, typically, you would have to get these components separately and then solder them, or use a breadboard if you want to go solderless. But the RDCOM Pico4ML with BLE, in this particular case, this one has Bluetooth Low Energy as well. This board has everything soldered on, so you can pick it up and just start using. Now, this board features an ARM-based microprocessor as well, and while it has its own SDK because it's not an Arduino board, it's also programmable using the Arduino IDE, and interestingly, it's also programmable using Python. So if you can get your hands on this board, I'm sure you're going to have fun working with it. And I hope that later on, you'll be able to see us demonstrate programming this board using the Arduino IDE. This is another board that is not made by Arduino, but by a company called SPAC Electronics. The board itself is called the SPAC Edge. It features an ARM-based microprocessor, and for that reason, it's suitable for tiny machine learning applications. The board comes with its own SDK, its own software development kit, but it's also programmable via the Arduino IDE.
Okay, so now we're going to cut over and take a look at the Arduino IDE and how you can get started working with it. So if you do not already have the Arduino IDE installed, you can go over to the Arduino website, which is arduino.cc, And you should have something similar to what I have on the screen. What you'll do next is go to the software link and click on it. Once you're done loading the page, you should have something similar to what I have on the screen. You'll see at the top that there's an Arduino web editor. So if you work in an environment where you would prefer to work with a web editor, you can go ahead and utilize that. A little down on the screen, you'll find the download section. And the first thing that you'll see there is the Arduino IDE 1.8. So that's a version 1 of the Arduino IDE. It's okay to go ahead and install that version, or you can scroll down. And if you go down a bit, you will find what they currently call future versions of the Arduino IDE. So there's a version 2 release candidate. And this is what I'll be using to demonstrate. So feel free to install one of the versions, whether Windows, Linux, or Mac OS. And I'll see you on the next screen once you're done with the installation. Okay, I've installed the Arduino IDE and I've opened it up. And what I have up on the screen is the work environment. I've maximized my screen so you won't see things like the file menu, but they're still there. If I put the mouse up, you will see that I have file, edit, sketch tools. I'll move the mouse away, and we also have this list of icons up here. And the first button is for you to verify any code that you have written in the IDE. The next button will let you upload your sketch onto your microcontroller. So the code that you write in Arduino is called a sketch. Next, we have new. So if you'd like to start up a new file so you can start programming, the new button will let you do that. And the next button will let you debug your code. So it will deploy to your microcontroller, and then you can run through it and do some debugging. The next button will let you open up an existing file. And the button after that will let you save. Now, this will let you select a board, and it will also show what board you have selected and connected. I haven't selected a board yet, but we'll get to that in a little bit. Now, I have an Arduino Uno R3, and I will connect that to the IDE. Now, once I have my board connected, I can go ahead and click on this drop down, and you will see that the first entry up there shows an Arduino Uno at a certain serial port. So I can go ahead and select this, and now I can work with my board. Now, I've gone ahead and opened up a certain example. You can find examples in the file menu. You can click on File, Examples. If you go to Basics and open Bare Minimum, you will end up with what I have on the screen. So to program in Arduino, there are two sections that you need in your sketch. You need a setup, which is at the top, and a loop, which is at the bottom. The setup contains code that you want to execute only once when the microcontroller boots up. The loop contains the code that you want to keep executing until the microcontroller shuts down. So think of it as, first of all, a preparation step, and then a continuous execution until you shut down the microcontroller. So to illustrate this, I'm going to open up another sketch, and this sketch is the electronic world example of Hello World, and it's called Blinky. Again, you can find it in the file menu, examples, basics, and then Blink. So if you're following along, you can go ahead and click it. I will go ahead and open up my copy of Blink. On the screen now, I have a copy of Blink. And at the top in green, you have a comment, and you can see all of the modifications that have happened to this file over the years. Now, if you go further down, line 25 is a comment that tells you what the setup function is meant to do. The entire setup function is contained between lines 26 and 29. For Blink, there's only one operation. To understand the operation completely, you need to understand the electronics behind microcontrollers, but I will attempt a very foundational explanation. There's one function that is called, and that function is named pin mode on line 28. It takes two parameters. The first parameter is a pin address, and we use a constant, we refer to a constant, and that constant is called LED_built-in. And then the second parameter is another constant, which is called output. Now, if you go back to line 27, the comment there says initialize digital pin LED built-in as an output. LED built-in is a constant. Pin mode is either input or output. In the microcontroller world, you deal with pins, and you either read the status of the pin or you write something out to the pin. Either ways, you deal with voltages, but depending on whether you're dealing with analog or digital, the kind of voltage that you deal with varies, but we won't get into that at this point. Now, once you're done with your setup, the next thing that you have is the loop. So the loop function runs over and over again, so it just keeps running until you shut down. Now, what we're doing here is on line 33, we're setting the voltage on that pin to a high voltage. And what that does is it turns the LED on. So recall that pin mode where we set the LED built-in. The microcontroller has a built-in LED on it, and that has an address. So LED_built-in is a constant that refers to that address. And when we do a digital write to that address and set it to high, the LED comes on. Then on the next line, we do a delay, and we delay for 1000. So the parameter is in milliseconds. We're asking the microcontroller to wait for a certain period of time, and in this case, it's 1000 seconds. So in essence, what we're doing is on line 33, we're turning the LED on. On line 34, we're waiting for a second. On line 35, we're turning the LED off. And then on line 36, we're waiting for a second. And so once you execute this, what will happen is that the LED on your microcontroller will continue to flash until you shut it down. So this is the basic anatomy of a sketch or a program in Arduino. There's a setup section and there's a loop section. Okay, so having looked at the basic structure, let's look at some other things. So let's talk about variables, data types, and operators. And to do that, I'm going to go back to the Arduino website so we can take a look at the documentation section. So back on the Arduino website, there's a documentation link. You can click on that, scroll to the reference section, and then click on that to open up the reference. The Arduino language reference has a number of sections. There's a section for functions, there's another section for variables, and then there's a third section for structure. I'm going to skip over the functions section for now and go straight down to the variables section. Now on the variables section, you will see that there's a section for constants. What you have in those constants is that these are values that you can use without having to redefine them over and over again in your sketches. Now you'll notice that we already made use of high and low, and we already made use of output. So when we set a certain pin to output, we used the constant. And when we were blinking our LED, we were making use of high and low. There are other constants that you can use. LED built-in is also defined as a constant, and that's why we were able to use it. Now, in the second column, we've got data types. And you can see various data types: array, bool, boolean, byte, character. I'm not going to read through all of them, but you'll see all of the data types that you're able to work with. And then there are also variable scopes and qualifiers, so constant, scope, static, and volatile. Now, once you know the variables that you're able to utilize, you can go ahead and utilize them in your code. The second thing that I want us to look at is the structure. So I'll scroll down a bit. Now, in the structure section, first we have sketch in the first column. I'll go to the second column and talk about arithmetic operators. So typically, when you write code, you might have a need to do some sort of computation. And you can see all of the arithmetic operators that are supported within the Arduino IDE. The first thing up there that looks like a percentage sign is called remainder or modulo, depending on where you're coming from. And what that does is it gives you the remainder of an operation. So as a very simple example, if you take the remainder of 5 divided by 2, the remainder will be 1, because 5 can be divided by 2 twice. That gives you 4. And then there's a remainder, which is 1. Then there's a multiplication operation, which doesn't need any explanation, as well as addition, subtraction, and division. And then there is an assignment operator. Now, directly below the arithmetic operators are the comparison operators. So the comparison operators are what you would use to check for certain conditions, especially if you're using control structure. So control structure is on the first column, is the second section. And so you have things like break, continue, do while. Do while is important. An example of do while is do something as long as a certain button is pressed, and then stop doing it once that button is released. So it lets you check for a condition and then execute a bunch of code as long as that condition is met. Else works together with if. There's a for statement, there's a go to statement, switch case, return, and while. Back to the second column, below the comparison operators, you also have Boolean operators. We will leave these operators for another session where we will go into them to illustrate them for anyone who doesn't have experience working with these types of operators. Okay, so I wanted to discuss functions, and I will scroll back to the top. Now, at the top are functions that are there for you to use to operate the microcontroller. I'm not going to go into nitty-gritty details. You'll have to read every single one of them just to get a sense of what it does. Feel free to click on any one and read the explanation. But what I'm going to do is I'm going to go back to the Arduino IDE now and show you an example of writing your own functions. So back in the Arduino IDE, I'm going to quickly illustrate writing a function. And what I'm going to do is I'm going to take everything that is within this loop and I will create a function out of it. So the first thing I do is put in a comment and call that my custom blink function. And I will define it as void my blink with my own curly braces. Now, once I do that, I need to explain what's going on. The first thing here is void, and void means that my function will not return anything. So the calling function doesn't need to expect it to return anything. Now, this empty parenthesis means that I will not pass a parameter into my function. Okay, but it will still work. So I'll go ahead and copy this out, cut it out rather. So I'll cut out my function and paste it in here. And just to check that everything works, I will go ahead and verify the code. Okay, so this error for missing fully qualified board name just requires me to pick a board. And I will go ahead and verify the code once more. And now the compilation is complete. We don't have any error in my new function. And so if I want to actually blink, what I need to do is put my blink in here with the parameters, and let's not forget our ending semicolon, and verify again. And this time around, we've reproduced my blink. But the point of a function is for us to be able to do something. So I'm going to do something here. See where we have this constant. I'm going to introduce the delay period, and let's call it D this time around. And so when I call blink, I will pass in a delay. And so that delay is what will work for us. And for that reason, I do not need to hard code it inside of the function. And so what I need to do back here is when I call blink, I can specify what the delay should be. In this case, I will make it 500 milliseconds, which is half of a second. Again, I will verify the code, and we can see that the compilation was successful. So I've just illustrated how to create a function. Now, how about variables? Well, 500 is an integer, so I can define the delay as my delay is 500, and then pass it in here. And now we've introduced a variable into our code. Okay, so there are two more things that I would have wanted to cover, which are arrays and pointers. But I think I will leave that along with some other things for the next webinar that we have. So for the next webinar, we will cover arrays, pointers, and serial communication. And then we will also add GPIO, which is general purpose input output, and hopefully some electronics within that. So I will stop here and thank you for attending, and let's see if we have any questions.